Hello viewers, I'm Kausalya. Today we are going to see an introduction about generation of three-phase voltages. So basically there are two types of supply system. One is single phase supply system and another one is three-phase supply system. And here in this video we are going to discuss about generation of this three-phase voltages, right? So here to generate a three-phase voltage we need a three-phase AC generator. Right. So, in the generator consists of two basic parts, right? One is known as stator and another one is known as rotor. So, as the name indicates, stator remains stationary, right? It always remains stable, whereas the rotor, it rotates, right? So, here the rotor is nothing but it is a magnet and stator consists of windings, right? So, here this is a simple diagram which shows AC generator comprising stator and rotor. So here the rotor, it is nothing but a magnet which rotates, and here the stator consists of windings in it, right? So here the windings are, you see, R dash form one winding, B dash form another winding, and Y dash forms the final set of winding, right? So here you see three separate windings, R dash, Y dash and B dash are physically placed 120-degree apart, right? They are placed 120-degree apart around the stator. So here the next thing is, as the rotor rotates, right? When the rotor starts to rotate, what happens? The magnetic field, okay, cuts the flux from the three coils, and therefore a voltage get induced in the coils, right? So in this case, what happens when the rotor rotates, right? It cuts the magnetic flux. So since whenever the magnetic flux gets cut, automatically an EMF or voltage is said to induced, right? So the voltage get induced in the coils. So the next thing is, you see, since the coils are placed 120-degree apart, right, the induced voltages in the coils are equal in magnitude and out of phase by 120 degrees. So here in this case, you see, since they are 120-degree apart, right? So the induced voltages in the three coils. What are all the three coils? R dash, Y dash and B dash, right? So the magnitude of the voltage induced in all the coils, they remain the same. For example, if the voltage induced is some 100 volt, the 100 voltage will be induced in R dash, similarly in Y dash and in B dash, right? But they are out of phase by 120 degrees. What do you mean by out of phase? They have a phase angle difference of 120 degrees. Okay, let me show you in the diagram. Then you will have a clear idea. So here, what is the case? Magnitude remains the same, but the coils are placed, since the coils are placed 120 degree apart, they are out of phase by 120 degree, right? So since they are having the phase difference of 120 degree, you see the general representation of the voltages are ER dash is, that is, this is taken as reference, right? So EM into sine omega t. This is the EM is the maximum value. Since the output is a sine wave, it is represented as sine omega t. What about Y dash? So here the voltage induced in Y dash is EM into sine of omega t minus 120 degree. So here this minus 120 degree is because the coils are placed 120 degree apart, right? And again B dash is EM into sine of omega t minus 240. Why here 240? Because here we are taking EM into sine omega t as reference. Right. So to this coil, Y dash is 120 degree apart. Again for this coil, this B dash is 240 degree apart. Right. That is the reason here why it is written as omega t minus 240. In other words, we can write it as EM into sine of omega t plus 120. Right. They both means the same. Okay. Am I making sense here? Since the coils are placed 120 degree apart, that is the output voltage is out of phase by 120 degree. So here the output voltages are represented by this values, right? So here these are all the output waveforms, right? So here when you look at this output waveforms, you see this is the output voltage of the coil R dash, and this is the output voltage of the coil Y dash, and here this is the voltage induced in the coil B dash, right? So here they all have the same magnitude, right? The magnitude remains the same, but you see there is a phase difference of 120 degrees between your R coil and Y coil, and similarly there is a phase difference of 240 degrees between your R coil and B coil, right? So this is clearly shown in this diagram, right? Yes. Then the next thing is we are going to discuss about the phase sequence. So what do you mean by phase sequence? The order in which the coils are arranged is known as phase sequence, right? So here just look at this diagram, right? So here we are having again 3 coils, right? And the 3 coils are placed 120 degree apart, right? Here one coil is R, another one is Y, and another one is known as B, right? So here in this case, you see we can consider the sequence as we wish. For example, here you can take the order as R, Y, B, right? Or even you can take the order as R, B, Y. Here the thing is we should always take one phase as reference. Okay, it is again up to you. Either it may be R, or it may be Y, or it may be B. Okay, it's not a thing. But the basic thing is we usually keep R as our reference, right? Because while solving problems, in order to remove unwanted things, we use it to keep always R as reference here, right? So here in this case, you see the peak value of voltage is same, yeah, but the maximum value are attained at different times. The order in which the alternating quantities attained their maximum value is called phase sequence, right? So the same thing which is explained here, you see the order, you see all the 3, they have the same magnitude, right? But what about the time here? R reaches its highest, that is peak value, in a short time, and Y takes some more time when compared to R, and B takes comparatively larger time than R, right? So this is the thing which is mentioned here. You see the order in which the alternating quantities attain their maximum value, right? Here what is the order? When you look at this diagram, it is R, Y, and B, right? R reaches initially, followed by Y, and then by B. So this is known as phase sequence, right? So this is what I have explained simply with this part, right? The phase sequence is the order in which we are considering. So here you see the voltage in Y reaches its maximum value, 120 degree later than R, and similarly voltage in B reaches its maximum value 120 degree later than in Y, right? So here the thing is again, it's up to you to take the thing. You can take that is the normal way to consider the thing is in clockwise, that is R, Y, and B. This is the normal order, right? If you consider this part, that is R, Y, and B, then that is known as positive sequence, right? And if you take it in reverse, then that is known as the negative phase sequence, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.